So in other words, this is not the right tool for the job. Law of sines is great for AS, and ASA. So is that all it's good for? It can also solve one other kind, the SSA. The SSA. Okay? The law of sines can solve a triangle with givens in the form SSA. You might say, wait a minute. What do you mean SSA? That's not one of the rules in geometry. It's not a uniqueness theorem, and it's not a congruence theorem, but you can certainly have a triangle that has sides 5, 11, and a 30-degree angle right here. There's nothing forbidden about this. So what do we mean there's no SSA rule? What does that mean? It just means that this triangle, under certain conditions, will not even have a solution. And in other conditions, it will have one solution. And in some cases, it could even have two solutions. It all depends basically on that angle right there. Okay, let me try and convince you. Let's say that I gave you, three chopsticks, okay? And one of them was length 10, and one of them was length 5, which is half of 10, of course. And I just gave you a third one, a really long one. I said, just take the third one home, and you can cut it to however long you need. Just make it however long you need it to be. But I really want it to form a 30-degree angle with the 10. So you take this home, and you're going to make a triangle for me, like a little project, okay? So you take your third chopstick, and you stick it on here like this, like that, and you make sure that this is a nice 30-degree angle like I asked. And then you cut your chopstick to size. Okay? Well, it turns out that what you just created is a right triangle. Okay? Isn't sine of 30 1/2? Right then. That must be a 90-degree angle. Right. But what if you had done, what if the instructions had been given where you had to make this a 6? So maybe I gave you a slightly longer chopstick. So let me erase this now. So you're given a 10 and, or actually let's do this. Let's make it a 4. Let's say I gave you a 10 and a 4. And I said, okay, now go home, take this third chopstick. You can cut it to whatever you need, but you got to make a 30-degree angle with the 10. So you bring the chopstick over here. You make a 30-degree angle right here, like I said. You know what? You're not going to be able to make a triangle. The little 4 segment is too short to reach. It can't reach. We've got a problem. And you're not allowed to squish this angle. I said it had to be 30. So now the 4 doesn't quite reach. It's not long enough to reach across this gap. Shoot. Okay, well, what if I had given you instructions that this was supposed to be a 6? So now it's a little longer. Same instructions. You got to make that 30-degree angle. So you bring your chopstick over here, your third chopstick, you set it on here like this. And you try really hard to make sure this is 30 degrees. Maybe you have a protractor at home. Well, it turns out there are two possible triangles you can construct. The one you see here in black, or the one you see here in red. There's two places you could put the 6th chopstick. It can go here or here. There's two possibilities. Okay, this is real. I'm not kidding about this. The 10, the 5, the 6, all that, the 4. You either get a triangle, or you get no triangle, or you get two triangles. See the problem? So SSA is just simply not a uniqueness theorem. It's not forbidden for any reason. It's not going to give us a unique solution every time. We can actually get 0, 1, or even 2 solutions to an SSA scenario. Okay? So I think we should do an example of a 0 solution case, a 1 solution case, and a 2 solution case. The math is not hard. Here's my first one. Solve the triangle if A is 10, B is 27, and beta is 31. Okay, you do not need to draw a picture. All you need to do is set up the law. Sine of alpha over 10 equals sine of beta, which is 31. over 27 equals sine of gamma over c. That third fraction, I don't know anything about that third fraction. I don't know the gamma or the c. But the first two fractions, I can cross multiply these. I get 27 sine alpha equals 10 sine 31. And then if I divide by 27, I get this. Okay, let's get the calculator out and try and find 10 sine 31 over 27. So let me get my calculator out here too. Okay, I get basically I'm getting sine alpha equals 0.1908. How do you get alpha? What button do you use? The inverse sine button, correct? We'll give you multiple answers on this problem. So alpha, your calculator will say is 11 degrees. I mean, I tried to round it to the nearest tenth, and it was 10.9968. So that's 11 degrees. And the thing about this is there's another possible answer, right? The supplement of 11 should also have the same sine value. Remember we said that sine of 180 minus theta is also the same as sine of theta? So you would put or 180 minus 11. In other words, 169 is another possible answer for alpha if it fits in the triangle. Okay? Now, in our triangle, we had originally that beta was 31 degrees. Right? Since beta was 31 degrees to begin with, I can understand having an 11 degree angle and a 31 degree angle in a triangle. I still got plenty of room left over for my third angle. But I can't understand how we can have a 31 degree angle and a 169 degree angle. That's already 200 degrees. I don't have any room left over for a third angle. See? So at this point, after writing the 169, I'm going to cross it out, knowing that it is not meaningful, and I'm going to go with alpha equals 11. Now, if that angle had fit in the triangle, I would keep it. Okay? But I'm not keeping it. It doesn't fit. Doesn't fit in the triangle. I've already got 31 degrees up here, see? Okay, let's move on then. Sine of alpha gave us 11 degrees there. So what we now know is that alpha is 11, but remember beta was 31, so I think we can find gamma right now. Gamma is just going to be 180 minus 11 minus 31. So what's that? 138. Okay, so here's your law of sines now. You now know that this is sine 11 over 10. Sine 31 over 27, and sine, oops, not degrees, just 27, over sine 138 over c. Now you can go ahead and solve for c. Just pick the second and third fraction or the first and third fraction. I'll pick these two. So c is going to be 27 sine 138 divided by sine 31. That's a 27, not a 2.7. Okay, so what is c? What does c turn out to be there? Let's see, 27 sine 138, all divided by sine 31. I'm getting 35.08. And that was my last unknown. So how many solutions did I get in the end? 1. 3 answers means 1 solution. Tomorrow we'll do the case where we have 2 solutions and even no solutions. I'm not assigning any 7.2 tonight because you're still working on 7.1, but we got a good head start on the lesson. Bring your book to class tomorrow. All right, so we were saying that yesterday, just basically that the law of sines can solve any triangle that has 2 given angles, or it can also solve a triangle that has 2 given sides if they are in the form SSA. Okay? That's actually what we have here. Does anybody remember how I told you you could easily recognize an SSA problem when you see it? I think I told this class period. 2 sides are given and 1 angle, right? So that could be SSA or SAS. But whenever you see an English letter and a Greek letter that match, like B and beta, or A and alpha, or C and gamma, if you have an English-Greek match like that, that's an SSA problem. Okay? So this is definitely an SSA problem, which means we have to be really careful. And when we set up our law of sines, we write sine of alpha over 10 equals sine of 31 over 7 equals sine of gamma over C. Okay? And then you would choose which 2 fractions you want to work with. I don't think we should even look at that 3rd fraction. Why don't we look at these 2? So we just multiply by 10. Sine alpha is 10 sine 31 over 7. We bust out our calculator and we type 10 sine 31 over 7. And the calculator says that sine alpha is 0.7357, almost 8. But it's on the screen, okay? So just keep it on the screen. We're going to be doing an inverse sine. Now, when you do the inverse sine, the calculator is going to give you 1 answer from quadrant 1. But we know actually from our last chapter that a statement like this has an infinite number of solutions, doesn't it? Remember that? Okay, so we're going to actually be more clever. We're going to write down more than 1 answer. But the calculator gives us this one. 47.4 degrees. That's what it says. Okay? Remember in the last chapter we said that another possible answer would be this point over here. Remember these 2 points have the same y value on the unit circle. Right? They have the same y value. So that means that this point over here we call alpha prime. This point alpha prime also is a solution. So we're going to do 180 minus 47.4. Which is obviously 132.6. Okay, so yesterday we did the same thing, and we actually threw out the answer. Does anybody remember why we tossed it? Yeah, the triangle wouldn't take it. We already had a 31-degree angle, and I think we got 169. Triangle's like, no thanks. Too many degrees. Thank you very much. But this time the triangle will accept either of these answers for angle alpha. Okay? All right. And the reason is the only other angle we know about is a 31-degree angle. And there's nothing wrong with having a 31-degree angle and a 132. You still have room left over for gamma. Okay, so what happens with this problem is it now splits, and we don't know alpha. There are just 2 possibilities. So the way our book labels this is they'll say that alpha is 47.4, and alpha prime is 132.6. They're both equally valid possibilities for alpha. Okay, let's pursue 47.4. And let's see where it leads us and what gamma it gives us and what C it gives us. And then we'll come back to this step and start over with alpha prime. Let's get a whole separate set of answers. Okay, so let's go this route. Let alpha equal 47.4. And your law of sines would look like this. And of course, your gamma angle, gamma is just going to be 180 minus the 31 minus the 47.4. So what's 180 minus 78.4? 101.6 right here, see? Okay, and now we can pursue this to get our C. So let's go ahead and take these two and cross multiply them. C would basically be 7 sine 101.6 over sine 31. Which is 13.3. And I think I said we would do nearest thousandth, or hundredth I mean, on sides. So that's C. And then the other possibility is that we go with, let alpha prime be 132.6. We take this possibility and set up our law of sines again. So it'd be sine 132.6 over 10 equals sine 31 over 7 equals sine of gamma over C. This time gamma will be a little different. This time gamma will be 180 minus 132.6 minus 31. Okay, so kind of ran out of room to show that. Maybe I can move this stuff down. Give myself a little more room. Okay. That bell seems a bit early to me, but 180 minus 132.6 minus 31 is 16.4 degrees, and then we could take this and cross multiply it to get C. So C is 7 sine 16.4 over sine 31. And that comes out to be 3.84. Yeah, 3.84. We'll call it C prime. And that's how you handle a problem with two solutions. Okay, you have the answers in the back of the book too, so even like a no solution problem, those ones are actually really easy. You'll see the answer in the back.